All right, guys, we're back. This one's going to be a short lesson. We are talking about limits to infinity. So what that means is I'm just going to show you this example here. So the way you would read this limit is the limit as x approaches infinity. I know that's kind of hard to see, but it says the limit as x approaches infinity. It actually says negative infinity of f of x equals, right? So I'm going to talk about how we solve limits as x approaches infinity. So I'll read this top part to you. The concept of limits as x approaches infinity means the following. What happens to y as x gets infinitely large? We are interested in what is happening to the y value as the curve gets farther and farther to the right. We can also talk about limits as x approaches negative infinity, so like this example here. This means what is happening to the y value as the curve gets farther and farther to the left, right? It's getting smaller and smaller. The terminology we use are the following. The limit as x approaches infinity of f of x and the limit as x approaches negative infinity of f of x. So let me write that for you so you can see it. This is the limit as x approaches infinity of f of x, and this is the limit as x approaches negative infinity of f of x. Right, so just like that. I'm actually gonna write it on this board because I think it's kind of hard to see there squashed in that text. So just in case you can't see, that marker's gone. The notation on that, it's like this. So that's approaching positive infinity, and the way you would write it for negative infinity is just like that. Or you guys will see I get really sloppy because when you're writing limit over and over again, I just end up going like that. So that's probably how you'll see me write it. This is the nice way to write it. The limit as x approaches infinity of f of x, the limit as x approaches negative infinity of f of x. All right, so let's go back to the notes sheet. Let this thing focus in again. So it says, note that it makes no sense to talk about the limit as x approaches infinity from the right, or the limit of f of x as x approaches infinity from the left. Why does that not make sense? Well, you can't approach infinity from the left or the right, right? Infinity is not a real number. You can't approach infinity from the left or right. It's not a real value. But so let's talk about this. It says there are only 4 possibilities for the limit of f of x as x approaches infinity, or the limit of f of x as x approaches negative infinity. The curve can go up forever. In that case, the limit does not exist. Or you could say that the limit is equivalent to infinity, equal to infinity, right? Which means it does not exist. Those are the same thing. Or the curve can go down forever. In that case, the limit does not exist, right? Because then the limit is equal to negative infinity, which still means it does not exist. So we're going to talk about these 2 possibilities first, and we'll talk about the other 2. Okay, so let's look at this problem. It says the limit, and I'll write it over here so you can see the limit as x approaches negative infinity of f of x. That's what this thing says, if you can't read it. So the limit as x approaches negative infinity of f of x. So I'm looking at f of x. Here's the graph. What happens as I approach negative infinity? So as I approach the left, right? So if we come up here, where does that say? We can also talk about limits as x approaches negative infinity. This means what is happening to the y value as the curves get farther and farther to the left. So if I was to follow this thing farther and farther to the left, what would be happening? Right? It would be getting larger and larger. It would be infinity, because this y value keeps getting bigger and bigger and always and always and always, which means this thing does not exist, which is this example here. And then what about this one? Same example. We're still doing limit of f of x as x approaches negative infinity. What happens here? If we go to the left, it's getting larger and larger and larger. So let's write this. I'm actually going to write it up here. So the limit as x approaches negative infinity of this function, if I go to approach the left, it's getting larger and larger, so it's infinite, but therefore means it does not exist. But what if I was doing the limit as x approaches infinity of f of x? So now instead of going to the left, I'm going to the right. What happens? Now it's getting smaller and smaller. So it's negative infinity. It's getting smaller and smaller. Still means it does not exist. Okay, let's do these last two real quick. What happens here? In this case, the limit as x approaches infinity of f of x equals. Okay, so these are, remember we talked about the four possibilities. These are the other two, right? So this possibility is that the curve can become asymptomatic to a line. In that case, the limit as x approaches infinity is a value, right? There's an asymptote. So if I look at this, since this is positive infinity, I'll write it down here so it's bigger. Excuse my allergies today. All my sniffling. And then this is the limit as x approaches negative infinity of f of x. What does that equal? Okay, so let's do the positive one first. If I'm going further and further to the right, what happens? Well, there's an asymptote here, and it's not going to cross that, right? So it's going to get closer and closer to 1, but it is never going to equal 1. That's why we can say the limit as x approaches infinity of f of x is 1. It approaches 1 as well. And now what about negative infinity? If I go back to the negative side, it looks like it's going to keep approaching negative 1. So that would be these two here. And what about this example? The curve can level off to a line. In that case, the limit as x approaches infinity is a value. So I'm going to write these larger down here again. The limit as x approaches infinity of f of x equals, and the limit as x approaches negative infinity of f of x equals. So let's do the first one. As it goes to the positive value, this thing, you can see it starts off here, and then it just starts going back and forth, waving back and forth around the x-axis. So it's getting closer and closer to 0. What about when you go to the negative infinity, to the smaller side? The same thing happens. It's hovering around 0, right? It's getting closer and closer to 0. So this is just almost the same as that, showing you how it can have a value. This one just doesn't have an asymptote, right? It's the leveling off. So really, this is nothing new. It's just instead of seeing what the function approaches at a value, you're looking at what the function approaches as you're going towards positive infinity or towards negative infinity to the left. Okay? See you next time.